Hello and welcome to Courses in the Time of Coronavirus. This is our first online recorded lecture. Here we're going to be talking about the renal system, which we started before break, but here we're going to be moving on and from the basic structures of the renal system and looking at the kidney and the bladder and all of that to filtration and reabsorption and how urine is produced in the kidney. So here we're looking at the nephron. The nephron is going to be our focus here. The nephron is the individual unit of the kidney that produces this urine. And we're going to be starting up here in the glomerulus and the Bowman's capsule. So the glomerulus is a cluster of little capillaries. And this cluster of capillaries comes in at the afferent arteriole where blood flow comes in. We get this meshwork of capillaries and then blood goes out through the efferent arteriole. And these capillaries are lined with podocytes, which are those foot cells that we talked about last time. And this is also called the visceral layer of the Bowman's capsule. This whole thing around the glomerulus is the Bowman's capsule. And on the outside, we have the parietal layer of the Bowman capsule, and that forms the outer structure. So blood is going to come in through the afferent arteriole. It's going to filter out into the Bowman's capsule. We'll talk about the details of that in a moment. And then it's going to be in that capsule, and that's going to go into the proximal convoluted tubule. Now, as I said, these capillaries are lined on the outside with podocytes. Podocytes are these extended cells with these feet, and there is a slit diaphragm between the podocytes that allows only very limited amounts of stuff out of the capillaries. So we have the normal endothelial cell barrier, we have the basement membrane that's forming that structure, and then we have the slit diaphragm. And altogether, that's going to work to keep all of the blood cells and proteins in the capillary, even while a lot of water and stuff that's dissolved in water is going out. Now, what's pushing it out? Now, this comes back to that POGL that we've been working on. So if you remember that POGL that hopefully you've been getting ready for, since it's due on Monday at 11:59 p.m., we have hydrostatic pressure coming into the glomerulus in the form of blood pressure. And this blood pressure is much higher than the capsular hydrostatic pressure. So the capsular hydrostatic pressure pushes back, but then we have a net pressure difference between these two. Now there is also the colloid osmotic pressure, which is going to push stuff back into the capillary because there's more stuff that's still dissolved in the capillary, in the blood, than is coming out because we have all those proteins and things that aren't coming out here. And so we have this colloid osmotic pressure pushing back, and when we subtract out the colloid osmotic pressure from the difference in hydrostatic pressure, that gives us the net filtration pressure, same as what you've been looking at in your POGL, and that's going to cause filtration out from the capillaries into the capsule. Now that's come out there is the filtrate. The filtrate is just the blood plasma without the large proteins. So we've pulled out all of the formed elements, both the cells and the platelets. We're holding them in, keeping them in the capillary. And all of the large proteins like albumin, a lot of our protein hormones, those are all staying in as well because they're being filtered through those slit diaphragms. They aren't letting these things through. Now, the amount of pressure that's coming into here is going to affect the filtration rate. Now, if blood pressure is higher, that means the net filtration pressure will be higher, and that's going to cause more glomerular filtration. Now, sometimes, however, we want to maintain an elevated blood pressure. And to do that, we need to have a feedback loop that's going to prevent too much blood from filtering in just because the blood pressure goes up. So looking at this, here's what happens when glomerular filtration increases. So start off with that increase in glomerular filtration rate, and that increases the flow through the tubule. And that's going to pass by the macula densa, which is a sensory system. And that macula densa is going to sense the increased flow and start releasing a signal. In this case, it is a paracrine signal, not an endocrine signal. So that is a paracrine signal that is going to just stay in this area and go to that afferent arteriole, the incoming blood. And that will constrict the afferent arteriole, allowing less blood through and decreasing the blood pressure in the glomerulus, which is then going to decrease the glomerular filtration rate. So this is just this feedback loop that when the glomerular filtration rate goes up, the macula densa sends the signal to decrease the pressure in the glomerulus, decreasing the glomerular filtration rate. Now we can measure filtration by looking at the amount of certain things that are in the urine, because some things are reabsorbed in the kidney, some things are added to the filtrate by the kidney, but a lot of things, some things you just wind up with whatever was in the urine, whatever was in the blood, now it's in the urine, in that quantity. And that means that regardless of how concentrated the urine is, however much was filtered out in the first place from the blood is now in the urine. Maybe in more concentrated if it's a higher concentration of urine, but now it's there. And so inulin is one of those things that is not reabsorbed and not added by the kidney. So however much inulin was filtered out in the first place, that is how much inulin is in the urine. So we can look at how much inulin was in the blood and how much inulin is in the urine. So we've got plasma inulin here. We can look at the amount of inulin in the plasma, and when we compare those, the amount that's in the total quantity of urine that we're looking at versus the amount that's in the plasma, we can see what our glomerular filtration rate is, how much plasma is being filtered out.